Lesson 81, complex numbers and real numbers, products of complex conjugates, division of complex numbers. All right, a complex number is a number that has a real part and an imaginary part. When the real part is written first, we say that we've written it in the complex number in standard form. So if we have a plus bi, remember I is when we have a negative, and it's imaginary, so we write the imaginary part second. Let's see. So on any of these, I guess I don't have the book. I'm not showing you the book. On any of these, the imaginary number is written second. Okay. If a equals 0, the number does not have a real part. Thus, the following numbers are complex numbers whose real parts equal 0. So 3i means that the real part is 0 or doesn't have a real part. Same for all these. If the coefficient of the imaginary part of a complex number is 0, we get a complex number that has only a real part. So negative square root of 2, okay, it doesn't have an imaginary part. Same with these two. Thus, we see that every real number is a complex number whose imaginary part is 0, and every imaginary number is a complex number whose real part is 0. Thus, the set of real numbers is a subset of the set of complex numbers, and the set of imaginary numbers is also a subset of the set of complex numbers. All right, so the complex number 4 minus 3i divided by 5 is not in standard form because it is not in the form a plus bi. That's why they normally separate out these fractions, as you've seen from other ones that we've done. Instead of saying 4 minus 3i all over 5, they do 4/5 minus 3/5 I. Okay, so this is written in standard form. This is not quite simplified. All right, products of complex conjugates. Remember, a conjugate is multiplying by the opposite sign. We have noted that the product of a two-part number and its conjugate has the form a squared minus b squared. So let's see here. They've written this out kind of weirdly, but 3 plus 5 times the square root of 2, the conjugate would be 3 minus 5 times the square root of 2. I feel like they've written this kind of weird, but first times first, and then the outer plus the inner, 15 times the square root of 2 minus 15 times the square root of 2 cancels out. And then last times last gives you 50, so 9 minus 50. So that's where they're getting the a squared minus b squared format. If we multiply a complex number in standard form by its conjugate, we get an answer in the form a squared plus b squared. The sign change between a squared and b squared is caused by the presence of an I2 factor in the second part of the product. Okay, so keep in mind I squared is the same as -1. So they're showing this here. If we get 12i minus 12i cancels out, so we have 9. -16, I squared is the same as -1, so -16 times -1 becomes +16, so then 9 plus 16. So you've got to remember that this I squared equals -1 when you end up multiplying conjugates here of I. Okay, division of complex numbers. The notation x squared minus 2x plus 7 over x plus 3 indicates that it can be divided by x plus 3. There's a format and a procedure we use, which we've done a lot of this dividing here to figure this out, and then our remainder goes over what we were dividing by. So if we encounter the expression 2 plus 3i over 4 minus 2i, we see that this notation indicates that 2 plus 3i is to be divided by 4 minus 2i. Unfortunately, there is no simple format or procedure that we can use to perform this division. However, we can change the form of the expression by multiplying above and below by the conjugate of the denominator. So we can't just write 2 plus 3i divided by 4 minus 2i like we could on this one, okay, because of the i's and having a part of it that's imaginary. So let's, just like we did with square roots, we're going to multiply by the conjugate. So 4 minus 2i, the conjugate is 4 plus 2i, but whatever we do to the bottom, we have to do to the top. So in the bottom, first times first, and then outer plus inner will cancel out. So we basically just have first plus last. And remember, I times I is I squared, and I squared equals -1. So if you get to the bottom here, I don't know if I'm cutting off, -4 times I squared, that's the same as -1, so it becomes a +4. Okay, and then the top, actually the same thing is going to be going on in the top as well, because we have our last times our last. 3 times 2 is 6, but I times I is I squared, so we have 6, but I squared is -1, so we have -6. So you can see here that was changed. Okay, then you're just combine everything. You're not going to put the whole thing over 10 or whatever our common denominator is, because you need to, it's not in standard form if the I is included in the top over the whole thing. So you got to separate out the fraction even if the bottoms are still the same. Okay. I don't know that it's necessary to do this other one. Here is where you need to understand, this is what I was just talking about, like both the denominators are 13, but you can't just leave it in this format. So you need to separate it out. -16/13 minus 2/13 I. This would be standard form, even though this looks cleaner and we're used to that. Because of the I, the imaginary part, you've got to separate it out like this. All right, that's it for lesson 81.